Every Friday on the Context Engineers Discord, we host CTOs, researchers, AI engineers who come and talk about technical details about their product or their research. This week, we have Nicholas Pipitone, who's the CTO of ZeroEntropy, who's going to talk about how we trained our state-of-the-art reranker zerank-2 and all of the improvements that we brought to this model from our previous iteration, zerank-1. Enjoy!
Okay, so the topic of today's talk is going to be zerank-2 and all of the improvements that it creates. First, as a quick refresher, I'll go over how zerank-1 works. zerank-1 introduced was a new way of training rerankers. And zerank-1 essentially takes your list of queries. Like the format of your query of your training data is going to be a query, 100 docs. You're going to have 100 docs for every query, and you're going to re-rank them. The goal of a re-ranker is to take in a query in a document and output a score between 0 and 1. Because that's going to be the goal. So if you have a large list of hundreds of thousands of queries, and for each query you have 100 documents that you want to re-rank, and then we're trying to train a re-ranker to be able to do this. And the way we annotate this is for every query, we do a bunch of pairwise comparisons between the documents. So which document do you prefer? Do you want, and then with those pairwise comparisons, and use those pairwise comparisons to assign ELO scores to all of the documents. Pretty similar to chess, or even just like the LLM leaderboard is done this way with pairwise comparisons. And when you have all of these query, 100 ELO scores, this is your SFT training data for the final ELO model. So that's essentially zerank-1 real quick, and then we'll talk about all of the improvements that we made with zerank-2. So first of all, we can go over some of the problems with zerank-1, some of the unsolved problems. First of all, when you have a bunch of ELO scores for the 100 documents, if you take all of those ELO scores and you add 1 to all of them, it doesn't change any of the differences between the ELO scores. So you're going to get like exactly the same predictions from them. What this means is that for every query, 100 document pair, there's going to be this term that I'll call the free bias. And the bias is unique for every query. It depends on the query. But you can take these 100 ELO scores and you can move them up and down by any quantity. Now, what that means is that this bias is probably important for the model itself, for the pointwise model, in the sense that if you have two queries, Q1 and Q2, where for Q1, all 100 of these documents are very relevant. But for Q2, none of the 100 documents are relevant. Well, what we did in zerank-1 was we just set the bias to be 0, meaning that the mean ELO was 0 for both sets of 100 documents. But that's much more confusing for the pointwise re-rank because essentially all of these are relevant, so they should get a high score, and all of these are irrelevant, so they should get a low score. And you don't have a good way to compare that. So that was one problem with zerank-1. Another problem that often comes is even just all of the different ways that you can write queries. Like, for example, one way is you could just have the query being a normal natural language query, like what is this or what is that? But really, there's a whole set of like instruction follow, where you could have like complex instructions. One way to even think about this is how the situation will sometimes change the way things are ordered. Considering asking a simple question, such as, what can I cook for dinner tonight? And there's two possible contexts that this could be asked in. One is if you're doing general web search, like you're literally searching over the web. And another context is you could be doing memory search, like, you're some agent helper, agent assistant, that needs to search over its own memories. So you could have documents that are directly relevant, like it can essentially be recipes for, I don't know, lasagna recipe. Or I don't know, if it's Thanksgiving, you can have a turkey recipe. But there are some documents that are very like situational. It depends on the context of your search. For example, one is I'm allergic to nuts. Now, if you do a web search, documents like this exist in the web. People say these types of sentences in forums. But the fact is, if you find a document like this with respect to the web, you know for sure it's super not useful. Like, it's very irrelevant. However, in the context of memory search, this type of document is extremely relevant. In fact, it's like one of the most relevant things that you could find in a memory if you're essentially trying to filter for what you can cook for. And these contexts kind of like can dramatically change the ordering and the importance of certain documents with respect to other documents. So the other thing that we wanted to add is like the ability for the model to react situationally to these types of contextual information of the content of what the agent is doing. And we've even taken that to the extreme in the sense that in the training data, we have injected like entire agentic workflows so that no matter what your agent is doing, the documents that you need for the agent to complete the workflow is like essentially dependent on what the purpose of the agent is. And we can even see that very strongly on instruction following benchmarks. This is the Mayor dataset. The Mayor dataset is like an enormous conglomeration of various instruction following. But to be specific, our focus was these types of agentic workflows for following, which is not exactly Mayor, but I believe we may release a dataset like this soon. So I'll go over the bullet points. One issue was the bias correction. One issue was the essentially context-dependent search. Another to really focus on was bilingual loss. So I think not very many people focus on like these types of bilingual context issues. It's very difficult to get good bilingual data or multilingual data is really what I mean here. And zerank-2, it's very strongly like y equals x. And this noise is not a problem. Like we don't want it to look at exactly y equals x because most likely like for all of this noise where it deviates, is noise where zerank-2 is like not agreeing with the LLM because the LLM is super noisy. This noise doesn't mean it's wrong. It's just better than, for example, when zerank-1 was like this. When you're looking at these two graphs for zerank-1 and zerank-2, remember the only difference between these two graphs are the bias. So we haven't changed how we sorted anything, and we haven't changed the ELO differences of anything. Like nothing with respective to relative sorting has meaningfully changed. So just by using the free bias that we have, we've been able to make this graph much more aligned with human expectations. And you can even see that, for example, in the I'm allergic to nuts situation. So on one hand, we also like adjusted our training data to try to improve situations like this, but we even ran experiments without adjusting the training data, just doing the bias correction. Like on the exact same like zerank-1 versus zerank-1 bias corrected, I'm allergic to nuts in zerank-1 would get a score of like 0.06. And then I'm allergic to nuts on zerank-2 was get a score of like 0.45. And this is purely the bias correction at work. Like this essentially is like aligning itself with human expectations. Because if you ask a human in the abstract, what can I cook for dinner tonight? And then you say for the document, I'm allergic to nuts. And you ask a bunch of LLMs, is this relevant or not? As mentioned, it will be noisy, but the mean is going to be about 0.5. Like if you ask a bunch of LLMs, half of them will say, no, that's not relevant. Half of them will say, yes, that is relevant. And you're going to get this mean. And you want the output score of your pointwise model to be near like this expected mean of like, because if you just ask people, like, is this document relevant to this query? Like, I don't know, kind of 50-50, like it's kind of relevant. It's exactly what you want. You don't want this small number like this. Because what's going to happen in production is you're going to set a threshold of like 0.35. You want to set a threshold. What I mean by setting a threshold is for your agent, you're going to filter any results that are below this score. You're able to save a lot of context by setting a threshold. And if you set a threshold and I'm allergic to nuts 0.6, then your agent it's going to pick a recipe that you're allergic to. And that's just not a very helpful agent. And now with zerank-2, this fixes the issue. You can set a threshold and you'll be able to then like essentially only get more relevant things. And we show that here of like setting a threshold. You can set a threshold whatever you want and align well with expectations. Like when you manually vibe check your data, it'll like align with what you think the relevancy should be. You can also see our competitor models don't do that well. So here's similarly completely uncalibrated. Voyage rerank 2.5 has some calibration, but the issue is that it's only really aligned when the relevancy score is extreme. Like when the relevancy score is very strong, okay, you get some positive score. And then when it's very, very low, you get a negative score. And anywhere in between, you can see it's an extremely noisy rectangle. You can imagine if I filtered for these edges. You can imagine if I like filtered out the edges and I'm only looking between 0.2 and 0.8, it kind of just looks like a random rectangle. Or really the R-squared is the best way to look at it. Yeah, you can just look at the quality of these fits. It was 0.4, and then this one's 0.55, and then this one's 0.8. This is going to align extremely well with your expectations.